Did you know that Earth's magnetic shield is weakening? And fast? This invisible force field, vital for life as we know it, is undergoing significant changes. Over the past 3,000 years, its strength has dropped by 30%, and the trend continues. This isn't just a minor fluctuation, it's a measurable and accelerating decline. But what if I told you this could be just the beginning of something much bigger? Something that has happened many times before in our planet's deep past. Stay with me, because I'm about to show you how this field protects us every single day. We'll explore what could happen if it starts to fail for good, and why we shouldn't panic. Earth's magnetic field is our first line of defense against threats from space. Without it, our planet would be a very different place. Imagine a world like Mars, dry, barren, stripped of its atmosphere, constantly bombarded by harmful radiation. That's the stark reality without this crucial protection. But what exactly is this field, and where does it come from? It's not a solid barrier, but a dynamic, ever-changing force. Its origins lie deep within our planet, in a place we can never directly observe. Deep inside Earth, almost 3,000 kilometers down, lies an ocean of liquid iron. This isn't just any ocean. It's a swirling, superheated metallic sea, constantly in motion. As our planet rotates, this massive liquid core also spins, creating powerful electric currents. These currents, generated by the movement of conductive material, are what create the magnetic field. Scientists call this incredible process the geodynamo, Earth's natural energy generator. It's a self-sustaining engine, constantly churning and producing the magnetic energy that envelops our world. The geodynamo is driven by convection, where hotter, less dense material rises and cooler, denser material sinks. This, combined with the Coriolis effect from Earth's rotation, organizes the flow into complex patterns. These patterns are what sustain the magnetic field, making it a dynamic and powerful force. This energy forms the magnetosphere, a huge, invisible bubble that surrounds Earth. It extends tens of thousands of kilometers into space, acting as a protective barrier. On the side facing the sun, the solar wind constantly pushes against this bubble, compressing it. On the opposite side, away from the sun, the magnetosphere stretches out into a giant tail, extending far beyond the moon's orbit. This tail acts like a cosmic windsock, indicating the direction of the solar wind. It's a testament to the immense scale of our planet's magnetic influence. And there's more. The magnetic field creates two concentric rings called the Van Allen belts. These belts are regions of highly energetic charged particles trapped by the magnetic field. They act like cosmic sieves, trapping dangerous particles and preventing harmful radiation from reaching the surface. Without them, our planet would be constantly bathed in high-energy particles, making life impossible. But not everything is stable. Today, our magnetic shield is changing faster than scientists ever expected. This isn't just a theoretical concern. It's something we can measure and observe. The biggest concern? A huge weakened area called the South Atlantic Anomaly. This anomaly stretches from South America across the Atlantic Ocean to Africa. Within this region, the magnetic field is significantly weaker, allowing charged particles to dip closer to Earth's surface. This increased radiation exposure poses a real threat to technology. Satellites passing through this region often suffer system failures, glitches, or even permanent damage. It's like they're flying through a hole in the shield, exposed to higher levels of radiation. Astronauts on the International Space Station also experience increased radiation doses when passing through this area. And that's not all. Earth's magnetic poles are moving. The magnetic North Pole is shifting rapidly towards Siberia, more than 50 kilometers per year. This is 3 times faster than its movement in the 1990s. This rapid shift has real-world implications. Imagine if your compass changed direction every year, requiring constant updates to navigation systems. This movement affects everything from aircraft navigation to smartphone compasses. Scientists are constantly updating models to keep up with its unpredictable path. This has happened before, many times. By studying ancient rocks, scientists discovered that Earth has flipped its magnetic field dozens of times throughout its history. These reversals are a natural part of our planet's geological cycle. The last major flip? About 700,000 years ago. During a reversal, the magnetic field doesn't just disappear overnight. It's a gradual process. The field weakens significantly, becoming unstable and chaotic. Instead of a clear north and south pole, small temporary poles can pop up in random places across the globe. Only after this period of instability does the field reorganize itself, with the north and south poles effectively swapping positions. This entire process can take centuries to thousands of years, not just a few days or weeks. It's a slow, drawn-out geological event. So, what would happen during such a reversal? While the magnetic field weakens, Earth doesn't go completely unprotected. Our atmosphere still provides a significant shield. However, animals that rely on the magnetic field to navigate, like migratory birds, whales, and sea turtles, would need to adapt. Their internal compasses, finely tuned to the Earth's magnetic field, would be thrown into disarray. This could lead to disorientation, affecting their migration routes and breeding patterns. Over time, however, species have shown remarkable adaptability to environmental changes. And if you're worried about radiation, here's something few people know. Our atmosphere is the true shield against most harmful radiation from space. It's incredibly effective, acting as a dense protective layer. Think of it as being as effective as a 4-meter-thick concrete wall. Even if the magnetic field weakens significantly during a reversal, the atmosphere continues to block the vast majority of harmful radiation. The primary concern would be an increase in ground-level radiation, but not to levels that would be immediately catastrophic for life. The biggest impact would likely be on our technology. And the best part, we have time to prepare. Scientists are not just observing, they are actively working on solutions and understanding the implications. Space agencies are already building better radiation-hardened shields for satellites, designing them to withstand increased exposure. Energy companies are strengthening power grids against potential solar storms, which could become more impactful with a weaker magnetic field. We're tracking all of this live with advanced satellite missions, like the Swarm mission from the European Space Agency. These satellites provide invaluable data, allowing us to monitor the field's changes in unprecedented detail. In short, yes, Earth's magnetic field is changing. It's weakening and the poles are shifting. But it's not a reason to panic. This has happened before, many times, over geological timescales. The difference is, this time, we're here to watch and understand. We have the scientific tools and knowledge to monitor these changes and prepare for their potential impacts. Our planet is a dynamic system, constantly evolving. The magnetic field is just one part of its incredible, complex story. Understanding these natural processes helps us appreciate the delicate balance that allows life to thrive on Earth. Did you enjoy this journey into Earth's magnetic future? Then hit subscribe, leave a like, and tell me in the comments. Were you more surprised to learn that the field is weakening, or that our atmosphere is what really protects us from radiation? See you in the next video.